Hello everyone. In this video we will continue talking about graphing linear equations into variables. Okay, this is from section 7.1 of Math in Our World, and this is example 3. Graph the equation x plus 2y equals 5. Now, you may know several ways to do this, so we will go through a couple different options. The first option for graphing a line is to find at least two solutions to the equation. And you may remember, maybe even from geometry, that if you have 2 points, there's exactly one line that passes through those 2 points. Alright, so if you want to draw a line, then if you can find 2 points on that line, then you know exactly what that line is. Alright, so I will just choose an x value and then find a y that matches. So let's say I choose x to be, x can be a 1. Alright, so then I'll substitute in 1 for x, and then solve to see what y is. Alright, so subtract 1, 2y equals 4, and then divide by 2, y equals 2. So that tells me that the point with coordinates 1, 2 is a solution to this equation. You could also choose a y and then see what the x value is that goes with it. So let's say I choose, let's pick a negative here. How about -2 for y? And then I would solve for x. Alright, so 2 times -2 is -4, and then add 4 to both sides, and x equals 9. So the point 9, -2 is also a solution. Alright, so let me plot those 2 points, 1, 2, and then 9, -2. And then your third step, connect them with a line. So I'm going to try to draw as much of the line as possible, just until it runs off the graph, and then put arrows on the ends to show that the line continues. And that's it. Alright, how do you decide what scale to use for the axes of your graph? So sometimes you end up with, points like 10, 100, or -42, +8. Alright, and you have a mix of kind of larger and smaller numbers, and depending on the points you choose, you may, run out of space on whatever the graph is that you've drawn. So one way to decide ahead of time what scale you're going to need is to find some of the key points. So if I knew, for example, where my graph crossed the axes, maybe it's out here and maybe down here, okay, then that would tell me how far, down I need to extend the axes, and if it's something large like 100, then maybe I would want to go by 10s or 5s or something instead of by 1s on those number lines. Alright, so those key points where the graph crosses the x and the y-axis are called the intercepts. So x-intercept where it crosses the x-axis, y-intercept where it crosses the y-axis. Alright, so think about how we would find those points. Well, let's just choose an x-intercept, maybe this point here. Alright, so notice that point is maybe a little small for you to see on your screen, but that's the point 4, 0. And let's say I choose another point on the x-axis, maybe here, and that's the point -2, 0. So notice that all of the points along the x-axis are all going to have a y-coordinate of 0. So this leads to your procedure for finding an x-intercept. Since all of the coordinates will be 0 for y, then you just substitute 0 into the equation for y, and then you solve to figure out what the x is. And then similarly for the y-intercepts, if we look at a couple examples of those. Alright, here's one example. That's the point 0.03. And here's another one. That's the point 0, looks like -5. And then all of these points on the y-axis will have x-coordinates of 0. So to find y-intercepts, you substitute 0 for x, and then solve for y. Alright, so let's try it out. Here's an equation, 2x minus 3y equals 6. Find the intercepts. Okay, so let's start with the x-intercept. So you substitute 0 in for y, and then solve for x. Right. Some people also like to just kind of cover up the y term, or cancel it out, because essentially that's what happens when you replace y with a 0. Right, -3 times 0 is going to be 0. Alright, 2x plus 0 is 2x, and that's the same as if you just didn't have that y term. Okay, keep solving for x equals 3. And then if you write that as a point, the x-intercept would be 3, 0. Alright, so I will plot that intercept and then go on to the y-intercept. Y-intercept, substitute 0 for the x and solve for y. Alright, or just cover up the x term. Alright, so then we have 0 minus 3y equals 6, which is -3y equals 6. Divide both sides by -3, and y equals -2. So the y-intercept as a point is the point 0, -2. And then notice when you plot it, it is on the y-axis, so that does give you an extra confirmation that you're on the right track. Okay, so we've plotted the intercepts, use them to draw the graph of that equation. So now we just need to draw a line through those 2 points. And my line's a little off. Let me try that again. Nope. Okay. And then I would just need to continue. Usually we try to extend it at least as far as the graph goes. And there you go. Alright, another concept related to graphing equations of lines is slope. And slope represents the steepness of a line. So first of all, how many ways can you think of to find the slope? You may have heard many different definitions. One of them is that slope is rise over run. You may have also seen something like delta y over delta x, or change in y over change in x. Alright, so what we mean by rise over run is, from some sort of a starting point, we look at, and then, to a second point. So for example, for this car, we look at the horizontal change, that's the run, and then we look at the vertical change, which is the rise. So we would say that from one point to the other, the car traveled 50 feet horizontally and 30 feet vertically. And then we just make a fraction to represent those two values. So rise over run, we do the vertical change, which was 30 feet, over the horizontal change, the run, 50 feet. And then you try to reduce and simplify this fraction. So first of all, the units will cancel, so you'll always just be left with a fraction without units. This is 30 over 50. And then in lowest terms, that's 3/5. Now what this does is it gives you a proportion, or a ratio that can be a piece of a proportion. This means that for every 3 feet that the car travels up, it has to go 5 feet sideways in order to gain those 3 feet vertically. All right. Now I can use this to find, lots of different changes. That's one of the nice things about slope. So assuming this car continues to travel on at that same rate, then I could, for example, find how many feet it would change elevation or the rise if the car went like 100 feet, 100 feet horizontally. All right, so that's one use for slope. Okay, so we have rise over run, and you could find that from a picture like here with the car. Let's do a second example of that. All right, the second car there has a rise of 10 feet for every run of 50 feet. So the slope of that road that the car is driving on would be 1/5. Alright, you may also know a formula for how to find slope. If you have 2 points, so we call them, the coordinates of the first point would be x1, y1, and then the coordinates of the second point would be x2, y2. And then we use an m to represent slope. Some people say that this is from the French word for mountain, and that kind of makes sense, you know, with the slope of a mountain. But there are a couple other stories of the origins for m, so you may want to look that up if you're interested, but it's kind of inconclusive why we use an m for slope. But we do, and we say that the slope equals, and then here's your formula. It's y2 minus y1 over x2 minus x1. Alright, so we can try this let's try it for the second car here. Let's assume that its starting point was the origin at 0, 0. Okay, so kind of picture, you know, your axes in here. And then that means that this point here would be the point 50, it's gone over 50, and up 10. Right, the point 50, 10. Now if we try to use the formula with those 2 points, okay, so I'll use 0, 0 and 50, 10. Alright, and then the slope would be y2 minus y1. So you can choose either point to be the second one. So let's go with the one on the right here. Alright, so y2 is 10, y1 is 0. And then subtract the x's in the same order. So if we chose 10 to be y2, then that means that 50 has to be x2. Okay, so x2, 50 minus x1, and that gives you 10 over 50, or 1/5, and that does match the same slope that we figured out before. Alright, so we have rise over run, that's one way to find slope. We have a formula. If you had 2 points, you can calculate a slope using that formula. And then another way to find slope is to identify it from an equation. So let's say you have something like y equals 2/9 x minus 4. Alright, and you may remember that in this equation, if it looks like y equals a number times x plus another number, the number in front of the x represents the slope. So I would say that the slope of this line is 2/9. Alright, let's practice. Find the slope of the line passing through the points 2, 3, and 5, 8. Alright, so I will choose this one as the first point as my x1 and y1, and then I'll choose 5, 8 as x2 and y2. Alright, so then finding slope, I can use the formula m equals y2 minus y1 over x2 minus x1. Substitute in the values, so y2 is 8, y1 is 3, x2 is 5, x1 is 2, and then simplify. So that would be 5 over 3. Now it's usually preferable to leave slopes as 5/3, This also does equal 1 2/3, but we usually prefer 5/3 because if you're working with graphs, we use this number to talk about from one point to the next. We use this number to represent how much we need to go up and over to get to other points. So it's nice to have a fraction with a numerator and denominator that describe the vertical and horizontal change. And you don't really see that with the mixed number version. Okay. All right, different types of slopes. You can tell from the graph of an equation at least the sign of the slope, and then also whether or not it's undefined or zero. So slopes that are positive, if they're greater than 0, the line will rise. And if you read this graph, if you picture kind of walking along from the left-hand side to the right-hand side, right? So walking left to right, if the line goes up, then the slope is positive. From left to right, if the line goes down, it's a negative slope, right? So you can use that fact. Let's say you're asked to find the slope of a line on a graph, and let's say you maybe say that this one is, let's see, a slope of -4. Well, I can tell from the picture that this should be a +4, not negative. Right? So you can use that fact to help you just prevent errors with signs. You may have the right number, but the incorrect plus or minus sign. Usually this happens more often with the lines with negative slope. So it would be more likely for a line that looks like this to say that the slope is like 2/3 or something, and to forget the negative sign. Alright, and then two other pictures here. If the line goes straight up and down, picture trying to ski a slope like this. Alright, this would be kind of like an infinite slope. It's so steep that you can't even really, work with that or ski on that. So that's an undefined slope. It's too steep to even put a number to how steep it is. Alright, and then a line that's horizontal and flat has a slope of 0. Alright, if you try to ski that. Okay, I'm getting carried away with the pictures here. If you try to ski that, it's too easy. There's no slope at all. It's not even like a bunny hill. Alright, now think about the points on those lines as an algebraic way to see, why we get slopes like that. Right, so if I picked out 2 points on a line that's flat like this, well, first of all, notice that they have the same y coordinate, the same height, but different x coordinates. They're in a different spot left to right. So maybe I have the points, let's see, maybe like 2, 3, and 4, 3. Alright, and if you wanted to plot those, you can just check and make sure, that those are at the same height. Well, look what happens when you try to calculate slope. Right, we need to subtract the y values, which is 3 minus 3. And then in the denominator, you subtract the x values. And then you end up with a fraction that's 0/2, which is 0. Alright, so really, anytime you have the same height, if your points are lined up side to side on a horizontal line, then the numerator of this slope fraction will always be a 0. Okay. Now we can try something similar to see why slope is undefined for vertical lines. If you choose 2 points on that vertical line, right, those definitely have different heights, but they're at the same x coordinate. So maybe they're at 3, 5, and then I've drawn a -1. Maybe it's at 3, -1. So now when I go to calculate slope, I have 5 minus -1 over 3 minus 3, and that's 6/0, and we know that anything that's a fraction over 0 is not a real number, that's undefined. Right? So it's because those points have the same x-coordinates, they're lined up right on top of each other, we'll always get this denominator of 0. Okay, finding slope from the equation of a line. Now, if I could rewrite this in this form, y equals a number times x plus another number, then I can just look at the equation and see what that slope is. Alright, so this is called slope-intercept form. Y equals mx plus b. M is the slope, and then 0b is the y-intercept. So notice if I plug 0 into the equation, if I substitute it in for x, because remember that's the process for how you find a y-intercept, substitute 0 in for x, and I get y equals 0 plus b, or y equals b. Okay, so the y-intercept is just whatever that last number is, the b. I like to think of it as like b for begin, so that's helpful as kind of like a starting point on a graph, the y-intercept. Okay, and then m for move, that tells you like a rate of change or a slope or a steepness or how to get from one point to another point. Alright, so what I want to do is to rewrite the equation of this line in slope-intercept form so that I can see what the slope is. So the way to do that is just to solve for y. Okay, so first thing I want to do is move the x term over, and I have negative 3y equals, and now I actually want the x term before the constant number. So instead of writing 15 minus 5x, I'm going to write this as negative 5x plus 15. And then finally I need y by itself. There's a negative 3 there, so I want to divide by negative 3 on both sides. And then this gives me the equation y equals, and now I actually want to divide both terms by negative 3. So I'm going to rewrite this and kind of split this large fraction up into two separate fractions. Right, so divide negative 5 by negative 3. The negatives cancel, that's 5/3 x, and I'm not going to bother to rewrite that as a mixed number, so I'm going to leave it. And then 15 divided by negative 3 is negative 5. So the slope for this line is just whatever you see multiplied by x, or 5/3. Alright, using slope-intercept form to graph. So I know the slope. Okay, and then here's my y-intercept, or b. So I'm going to begin at the y-intercept, so I would plot negative 6 on the y-axis. And remember that that's the point 0, negative 6. And then I would use the slope to move from there to a second point on the line. So slope is rise over run, or the change up and down, and then the change side to side. So if it's a positive number in the numerator, you'll go up. If it's a negative number, move down. And then in the denominator, since we're going side to side, if it's a positive number, go to the right because that's where the positive numbers on the x-axis are. And if it's a negative number, go to the left because all of the negatives on the x-axis are to the left. All right? So begin at your intercept, right? And then you would move. Now this one has a slope of 5/3, so move up 5, and then move over 3, and plot the point where you end up. and that's right there. So that's the point 3, negative 1. And then draw a line through those points. All right, let's try another one. Graph y equals negative 2/3 x plus 7. So start at the y-intercept, which is 7, the point 0.07. And then the slope is negative 2/3. Now the negative can go either with the 2, think of this as like a negative 2 over 3, or you can think of it as a positive 2 over a negative 3. So either one. So I have two options. From that point, I could either go down to, if I'm thinking of it as a negative 2, and over 3, all right, or I could go up 2, and then left 3. So I end up at two different points, but notice that that's okay. They're actually still on the same line. All right, so you can move either direction. All right, let's do one more example on the same graph. What if you have a slope that doesn't look like a fraction? Something like y equals 3x minus 2. All right, well, 3 can be written as 3 over 1, so it still is a fraction. You're just moving up 3 and then over 1. And then notice it's not a 0, it's over 1, not 0. All right, so this one I would start at negative 2 and then go up 3 over 1 and end up here. All right, and then if you have something like y equals 3x minus, let's say it's like 1/5, then on the graph, just do your best to estimate where negative 1/5 is. Okay, and you just want to be as accurate as possible. So that's between 0 and negative 1, and it's pretty close to 0. And then you would go from there. All right, your slope, let's see, up 3. Again, it's going to be a little bit below one of these lines and over 1. So that's more of an approximate graph. All right, we will end with talking about how to graph horizontal and vertical lines. Something like y equals 3 and x equals negative 6. All right, so remember, if we go back to using points to graph lines, then to graph y equals 3, I just need to find two solutions that make that equation true. All right, so now there's no x to even substitute in for, so that means that I can pick whatever I want for x. It doesn't really matter. However, the only thing I can substitute in for y to make this a true equation is a 3. So whatever point you choose, the coordinate for y has to match what you see in that equation, and then you can pick something for x. So let's do like a 2 and a negative 4. Now if I graph those 2 points, 2, 3, and negative 4, 3, all right, and then draw a line through them, notice this is a horizontal line. All right, or in words, basically what we're saying when you see y equals 3, you're saying draw the line that has all the points that have y coordinates of 3. So all of those points are going to line up horizontally all along here. Now x equals negative 6, this is saying draw all of the points that have an x coordinate of negative 6. And then we don't care what the y coordinate is, it's not mentioned in the equation, so it can be anything. You could choose 0, you could choose 1, 4, as long as the x coordinate is a negative 6. So those would be, let's see here, negative 6, 0, negative 6, 1, negative 6, 4, and they're all going to line up on a vertical line. right? And that's the equation x equals -6. Okay, graph the lines x equals 5 and y equals -3. A little bit of a shortcut to choosing points. X equals 5, just go to where x is a 5 and put like a little tick mark, and then just draw a line straight through that, because those are all of the points that have an x coordinate of 5. Y equals -3, go to the y-axis, find where y is -3, and then draw a straight line through there. And that's it. What about x equals 0? Well, go to where x is negative, or x is 0, and then draw a vertical line through there. Right? Now, points, if you need points for this one, just pick out some points where x is 0, and then choose something for y. And then that'll help you get the vertical or horizontal straight. Alright, so here's 0, 1, 0, 2, 0, 3, and then that's a good reminder that this goes up and down. How about y equals 0? We want points with a y coordinate of 0. X can be anything. And if you look at those points, here's 1, 0, 2, 0, 3, 0. So y equals 0 is this line, or just the x-axis. Right? Okay, that's it. So in this video we've talked about graphing linear equations. We talked about a couple different forms. We had standard form, ax plus by equals c, and slope-intercept form, y equals mx plus b, and then we had horizontal and vertical lines, x equals some number, and y equals some number.